Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. Welcome to the 100th episode of Energy Talks. Over the past 4 years, we have spoken with experts in the fields of power system testing, data management, the digital transformation of the power grid, cybersecurity, and mastering the challenges of a rapidly changing power system. I would like to take this time to thank each of our over 150 expert guests who have shared their experiences and insights on these various topics affecting the power industry. I also thank our listeners like you who continue to join Energy Talks to get informed about the latest power system developments and trends and to get inspired to solve daily challenges in the field. So to all our listeners, I kindly ask you to take the time to let us know why you enjoy listening to Energy Talks and which topics interest you the most. Also, let us know if you have a topic to share and would like to be an expert guest on Energy Talks. Simply write us your feedback in an email to podcast@omicronenergy.com or give us your feedback on Spotify if you listen to us there. Here are some interesting Energy Talk statistics that I'd like to share with you. Did you know that our community of listeners continues to grow with over 10,000 streams per year from all over the world in 175 countries? Did you know that most of you listen to our episodes via Apple Podcasts, Spotify, and even on YouTube? Did you know that we regularly broadcast 2 episodes a month or 24 episodes a year, which after 4 years equates to roughly 46 hours of content for you to listen to? Did you know that slightly over a third of our episodes have been featured in one of 7 Energy Talks mini-series covering various topics in detail? Our episodes are focused on different types of power system testing, like testing protection systems, rotating machines, power transformers, instrument transformers, and grounding systems, as well as using partial discharge measurements and monitoring to diagnose the condition of electrical insulation. We have also spoken with our expert guests about electrical power safety, the importance of testing device calibration, as well as the changing landscape of power grids integrating renewable energy, the digital transformation and cybersecurity, and we've even talked about wildfire mitigation. It is never too late to listen to an episode of Energy Talks, so be sure to go back and listen to the episodes you may have missed, which are of interest to you. Our goal with Energy Talks is to share the knowledge of our guest experts with you, to provide you with insights about current and important topics, and to inspire you through the experience of others to solve daily challenges. Of course, essential for us is to help listeners like you keep energy systems running reliably to avoid blackouts. If we look at recent headlines, blackouts have caused havoc in major infrastructure hubs like London's Heathrow Airport. These incidents clearly demonstrate how being prepared is key to ensuring a reliable power system. For example, in our episode 58, I spoke with OMICRON experts Friedrich Almer and Daniel Wiesner about how to prepare and prevent blackouts in the power grid. I would now like to replay some segments of this episode to recall what they described as essential points to consider. Hello, Friedrich. Hello, Daniel. Welcome to this episode of Energy Talks.
Hi, Scott. Nice to be here.
Hello, Scott. Thank you for having us.
What are the risk factors for blackouts, and how does the growing complexity of energy systems play a role in that?
So first of all, for a stable and reliable electricity supply, the generation of electrical energy has to equal the demand at any time. And if the system is in this balance, we have a system frequency of 50 hertz or 60 hertz, depending on in which country you live. Now, if the generation and the consumption differ, it results in a changing system frequency. So if the generation is too high, then the frequency increases. If the demand is too high, the frequency drops. We are very dependent on these 50 or 60 hertz since a lot of machines and devices rely on it. The generators in the power plants, they are designed for a certain frequency range as well. Now, with the so-called centralized generation, large-scale power plants generate the required electrical energy, And those power plants can be also quite far away from the consumers, can be connected with long transmission lines. And in this case, we have quite simple unidirectional load flows from the generation to the consumers. And in many countries, this has changed or is changing to a more distributed generation. So meaning less of the large-scale power plants with rotational energy, and instead a lot of smaller distributed infeeds, especially from the renewable energies such as photovoltaics, wind turbines, and hydropower. And this renewable infeeds in all sizes with bidirectional load flows across the different voltage levels. So you could say that the system has become more complex, and there is a certain volatility in generation and a volatility in the loads as well. And you can imagine that maintaining the system balance and the 50 and 60 Hz frequency has become more of a challenge, especially for days or hours with a high energy demand and with maybe less sun and wind. And combined with further reasons and incidents, this can potentially lead to outages or even in the worst case to blackouts as well.
Okay. So Daniel, what could be possible solutions for the challenges which come with a high integration of renewable energies?
So basically the big challenge is how to store the energy from the renewables to prevent these grid instabilities and to thereby prevent blackouts. And there's a lot of research and development ongoing in this field. So the technology of battery storage systems has improved a lot, and there are more battery storage system installations as well. So you can see that there's a lot going on in this field. And besides the storage, also the infrastructure needs to be expanded to be able to handle the changing load flows and the increased power demands. So this means that there are additional transmission lines, cables, transformers, and so on for the development of our transmission and distribution grids required as well.
How equipped is the European grid to prevent widespread blackouts, or is it?
There's always a certain generation reserve available to react on changing demands and to react on further incidents. So in the grid, we have so-called fast dispatchable plants, such as pumped storage hydro or gas power plants, and they are used for load and for peak matching. So peak matching meaning there's a short period of time with high consumption then available. And those power plants then quickly increase their generation to stabilize the grid. And this also if there's a low infeed from non-dispatchable energy sources such as wind or solar. And also energy can be imported from other grids such as the UK or the Nordic countries, and this on demand and on availability. Also, there is a N-1 or N-X criterion, meaning that the grid shall be able to handle single outages of, for example, transmission lines, of cables, of transformers, etc., without power outages. So there's always a certain redundancy in our system. As well, the European grid or the companies there, they train this scenario of a blackout regularly. Here also OMICRON accompanied several utilities during so-called black start and grid restoration tests. So we provided their devices and expertise for synchronous distributed measurements on several critical points of the grid. And as mentioned, those scenarios, including widespread blackouts, are trained and prepared thoroughly by the responsible companies. And I think we can say that in Europe we have a very stable grid, very few outages, and are very well prepared also for possible blackout scenarios.
If there is a blackout, what can be done and how quickly can the power grid supply electricity to various households and businesses across the country or region? How does this work?
That highly depends on the possibilities of the local grid and, of course, on the cause of the blackout, whether critical components got damaged, for instance. In Austria, we have power plants which are, as Daniel also already mentioned, black start capable. That means these power plants can start and operate without an external supply. In simple terms, it works like this. First, the controlling system is powered by an emergency power supply like a battery or fuel-powered generator. Next, the turbine must start turning. In the case of an hydroelectric power plant, we have water flowing through the turbine. You can imagine this works like a water wheel connected to a generator. After the generator starts, the supplier can begin rebuilding the electrical grid with the first loads, like lines, transformers, or even first consumers, and step by step synchronize more power plants and more lines, more transformers, more consumers, and so recreate step by step and stabilize the electric grid. Here also, the balance between the generation and consumption plays an important role again.
So how does the diagnostic testing of electrical assets help operators ensure a safe and ongoing reliable operation?
First of all, it is always good to know the current condition of the components within a critical infrastructure like the electrical energy system. Therefore, system providers make use of different inspection and maintenance strategies depending on the type and the importance of the components. The importance of the components are defined by different criteria and could depend on the type, the price, the voltage level, the location, and the supplied customers, and so on. The least effort are event-oriented strategies, not really critical components. There you only invest time and money when something already happened and you don't have an inspection or maintenance interval. Then there are classic time-oriented strategies. For instance, you inspect and maintain the components on fixed time intervals. For instance, all 4 years, you test if your protection system works properly, or all X years, you maintain your transformers within your grid. And lastly, there are the condition-oriented strategies. Here, you first inspect and then maintain depending on the condition of the component. The inspection to assess could be done in a time interval, but for really critical components, it is more common to use monitoring systems, which can detect and report condition changes automatically.
How can the use of cybersecurity solutions help prevent blackouts?
Yeah, so state-of-the-art substations, they include large networks and a lot of digital communication. And cybersecurity is becoming and has become more and more of an important topic. We can also see several new national and also international regulations, including cybersecurity requirements for a critical infrastructure. So this is really seen as a potential risk for blackouts.
Friedrich and Daniel, thank you very much for joining me for this conversation about preparing for, and most importantly, preventing blackouts in power grids.
Thank you very much, Scott.
Thank you, Scott.
As you can gather from this featured episode, a reliable power supply is influenced by a wide variety of factors. With the help of our field experts, we will continue to keep you up to date and share practical knowledge and experience about these topics, including the essentials of efficient power system testing, effective power system data management and analysis, the digital transformation and successful cybersecurity practices, and meeting the constant challenges of evolving power grids. I kindly ask you again to take the time and let us know why you enjoy listening to Energy Talks, and of course, which topics interest you the most. Also, let us know if you have a topic to share and would like to be a guest on Energy Talks. Simply write us your feedback in an email to podcast@omicronenergy.com. Please also be sure to recommend Energy Talks to your colleagues and give us a 5-star rating and also feedback on Spotify if you listen to us there. Thank you again for listening. OMICRON has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please be sure to join us for the next episode of Energy Talks. Goodbye for now, everyone.